Let's start with the birth of relief valve symbol. So the relief valve symbol has very good correlation with how the valves are being manufactured. So for example, here's your normal valve which will have a generic valve symbol like this. Now in an angle valve, if you will see, there is something different in the bottom connection, right? Similarly, the valve symbol also follows the same. You will notice here a pattern, right? As it is starting from bottom, even the symbol starts from bottom as the inlet. Now there's one more thing here. If you look, the relief valve lower section is almost very similar to that of an angle valve, and on top of it there is some symbol which kind of correlates to the spring. So we can say in simple words that combination of an angle valve symbol plus a spring symbol, when you put together, basically comes together and forms the relief valve symbol. And the functioning of the relief valve is very simple to a pressure cooker. Remember, in a pressure cooker the whistle pops up when the pressure limit exceeds, right? Similar is for a relief valve. The relief valve will pop up when the set pressure exceeds. So one of the most important parameter in a relief valve is nothing but the set pressure. So for that case, imagine here's a vessel and here's a relief valve put. So in PNID you will usually see something like this set at the rate 100 psig. So this is nothing but your set pressure where the relief valve should pop up as per process requirement. Now this is sometimes written as SP at the rate 100 psig, or only the value is written at the rate 100 psig. But because this is such an important value, you would find it that any value which is written near to the relief valve is going to be its set pressure. The next important thing which is written in the relief valve is nothing but 1D2, something like this. Now what does this stand for? This is as per the APA standard designation. The first letter stands for nothing but the inlet size of the relief valve. So here in our example, 1 would stand for 1 inch of the relief valve as the inlet side. Then the second letter actually stands for the orifice designation. So the API has standardized various orifice designations. So here the relief valve is having the orifice D. So a certain amount of square inches of area is defined as per the relieving capacity of the relief valve, and that is been designated by various letters. Then finally the last letter stands for nothing but the outlet size. So here if you see, the outlet side is 2 inches. Now remember one very important thing, that never will the inlet size ever be greater than the outlet size for any relief valve. If you see such a case, then you will have to highlight it to the process engineer. There has been some mistake in drafting the PNIDs. Let us look at one another example of comparing between a normal pressure relief valve and a vacuum relief valve. What is the difference between the two as per the ISA 5.1 symbology? So if you see here, let us have two vessels. The first symbol is for pressure relief valve and second is for vacuum relief valve. There is small difference in it as per ISA. If you see the arrow here and the arrow here, there's a difference in between the flow direction. So let us try to understand this. Imagine there is excess pressure in this vessel, then the relief valve would be relieving this pressure out to the atmosphere. Finally, but in terms of vacuum relief valve, if there's a vacuum created inside the vessel, then it will push the air from outside, the atmospheric air, inside the vessel to remove the vacuum condition. So this can sometimes be understood by the arrow. If certain PNIDs are not following such a symbol, then for that case you can understand by the naming convention. So if you see here, for pressure relief valve you will have is PRV, while for vacuum relief valve usually it is represented as PVRV, pressure vacuum relief valve. With relief valve symbol, you will find something amazing happening in the recent PNIDs, especially this symbol here. Now this symbol stands for rupture disk symbol. Now rupture disk is also further divided into vacuum rupture disk. So what is the difference? Similar to, remember, of relief valve, for normal cases the direction will be shown upward, that is the pressure is being released out to atmosphere. For vacuum rupture disk it will be shown going downward, so basically the air is sucked from the atmosphere into the tank. Now let us see how this combination looks like. So imagine here's your tank, here's your rupture disk, and here's your relief valve assembly put together. One more thing to note is this symbol here stands for rupture disk and this symbol stands for relief valve. It should not be confused that what is this new symbol that has come up in the PNID. It is basically a combination of relief valve symbol plus rupture disk symbol. Now this symbol which is shown here is basically for ISA 5.1 symbology. But sometimes like this symbol which we see here, this is not the standard symbol but has been found in a lot of PNIDs. So if you see this symbol, then even this symbol stands for a ruptured disc symbol. Now you would have the next question, that why are we having a combination of ruptured disc plus relief valve? Is there some specific need to it? The answer is yes. And it's a very important technical point to be noted down. The first thing is, a lot of fugitive emission control has to be monitored. So for example, fugitive emission is basically how much toxic gases is your instrument leaking into the atmosphere. So all the government guidelines, especially in the US, have been given a very strict control that the leakage should be such minimum amount, for example from your control valves, on off valves, relief valves, etc. So what happens is, when the rupture disc is put in combination, the rupture disc will actually isolate and would not allow any leakage if it exists in the relief valve to go into the atmosphere. So it acts as a barrier to it. So you have very tight fugitive emissions controls can be met with this combination. The second thing is, it protects the relief valve internals from process. So imagine if the process is acidic or something which is very corrosive, because the rupture disc is in between, it is going to act as a barrier and the internals of the relief valve will be protected. So it's a logical conclusion that it will have a longer life as compared to your normal relief valve assembly. And finally, the another important thing to know is easy isolation of relief valve. So for example, if your relief valve has to be removed because the rupture disc is going to act as a barrier in between, it is going to be easier to isolate and maintain the relief valve procedures. Wait, if you are dead serious about learning core engineering, and if you're an engineer who has an experience of 0 to 7 years, then I'm very, very positive that you would find this course very helpful as per ISA 5.1 standard. People have said it's a clickbait because you get to learn so much more. This video is part of that entire course. The link to the entire course is given in the description and in the comment section. If you have any doubts, I would be extremely happy to help you. If not, don't worry, let's meet next Saturday and learn something new again. Till then, happy learning.